Welcome once again to this class. Today we are going to look at the topic binary operation. Before we proceed, let us look at our specific objectives. At the end, you are expected to know the definition of binary operation, table of binary operation, inverse of binary operation after the identity element. Binary operation simply means the rule of combining two elements of non-empty set. If I have A operating on B, could also be B operating on A. The rule of combining two elements of a given non-empty set. Terms associated with binary operation. Number one is commutativity. Talking about commutativity, if you have an operation A operating on B, if this will be the sentence as B operating on A, we now say that such is what? Commutative. Such an operation is commutative. Now considering the next term, associative, we have X operating on Y operating on Z. If left-hand side could also be written this way, X operating on bracket Y operating on Z, they are said to be what? Associative. For instance, let me say under commutativity, if A is 1, B is 2. Look at it. The formula, assuming the formula here is A operating on B, B equals A plus B. If A plus B will give us the sentence as B plus A, we'll term it what? Commutativity. It is commutative over the operation. The same thing goes to this. Now let's check this. A plus B equals 1 plus 2, which will give us 3. Then B plus A equals 2 plus 1, which will give us 3, meaning they are commutative over the operation. Associativity, given that X equals 1, Y equals 2, Z equals 4. And we'll have a formula X plus Y, maybe times Z. Following this operation, 1 plus Y. What is Y? Y is 2. Then multiply by 4. This will give us 1 plus 8, which is 9. Then when we interchange this, is it going to be this? Is it going to produce the same result? Let's say if we have Y plus bracket X times Y, Z. Let's see if it gives us the same solution. Our Y is 2 plus bracket 1 times 4. So 2 plus 4 equals 6. You can see the first solution is different from the second solution. In this case, you say addition under associativity is not giving the exact result. Therefore, it is not what? Associative. Distributive is almost the same thing with commutativity. It just at times in distributive, you can have minus and plus all together. Let's say A plus B plus C. Here we now have B plus bracket A plus C. When we assign values to this, if A is 2, B is 3, C is 4. Let's say 2 plus 3 plus 4 equals 9. Is it the same thing as starting with B first? B is 3 plus bracket 2 plus 4. This is 3 plus 6. So it's also 9, meaning it is distributive over the operation. So you need to have knowledge of this associativity, commutativity, and distributive as a term associated with what? Binary operation. Because in WAEC or NECO, a question will be given to you which will demand asking you, is it distributive over this or that? We'll get to there when we start to make use of our exam guide using past questions and answer. Past questions. Okay. Now, table of binary operation. Let this be a binary operation over a set A such that A equals -2, -1, 0, 1, and 2, and is defined by A operating on B equals A plus AB. Design a table for the operation. No cause for alarm. All you need to know that a particular value was assigned to A, which is the values includes -2, -1, 0, 1, and 2. It has been assigned. Now we are taught to design a table for this operation. Good. What are we dealing with? We know that A operating on B equals A plus BA. AB. Meaning we will have A and B to be contained in our table. That table is dealing with what? Horizontal and what? Vertical axis. Here we contain A operating on B. Whereby this side we assign it to A, this side we assign it to B. Then what are the values we have? -2, -1, 0, 1, 2. The same thing goes this way. -2, -1, 0, 1, 2. Okay, this is it. Now, the whole journey starts from here. Recall that A operating on B equals A plus AB. Meaning, if here is for A, I'm starting with this. This will give me -2 plus -2. times minus 2. This will give me minus 2 plus 4. The solution becomes minus 2 plus 4 equals 2. You write 2. Then for this, minus 1, which is A, plus minus 1, let me put in brackets, times who? B minus 2. This will give us minus 1 plus 2 equals 1. The here is 1. This is for 0, 0, that is A, plus A times B, or is B minus 2. This will produce what? 0. All of this, 1 plus 1 bracket minus 2 will give us 1 minus 2 equals minus 1. You write. Then A, which is 2, plus 2 times minus 2. This will give us 2 minus 4 equals minus 2. You write. The same thing goes here. If you want to get this place, you start from here again. That is, A is minus 2 plus A times B, which is minus 1. Minus 1, which is A, plus minus 1, which is A times minus 1, will give us minus 1 plus 1 equals 0. Okay, for 0, provided that A is 0, everything will be 0. Now for plus 1, 1 plus 1 times minus 1. This implies 1 minus 1 equals 0. For 2, A is 2 plus 2 times minus 1. So you can see here is producing 0 all through. This against this. Minus 2 plus minus 2 times 0. This will give us minus 2 plus 0 equals minus 2. You write minus 2. For 1, minus 1, which is A, plus minus 1 times 0, will give us minus 1 plus 0 equals minus 1. This is how you continue to solve until you are done filling this table. So whenever a table is given to you under binary operation, take your time to multiply out everything, especially when you are dealing with theory. You can see the sample on how you can do it. At times, instruction may be given to you. At times, they will tell you the operation, the value given to you, then mode, whatever, maybe mode 3, mode 4. It means when you are operating under mode, if your solution is greater than the mode, you divide and write the remainder as your solution. Okay, now let us take a look at another thing under this topic. Binary operation calculation. Now I want to consider the identity element. In binary operation, we believe that A operating on B equals E. That is to say, if a formula has been given to you as this, plus AB, just like we had before. So, the first one against the second one will produce this. Meaning, if you are to solve A operating on, okay, let's say this operating on this equals A. Your first one, whatever you see as the first one is your A. So the second person is going to be who? The identity element. And it's going to produce the first one. So that's just the rule guiding it. Well, let's look at our questions. A operating on identity element equals A. Like we'll have inverse element. If A operating on this equals A plus BA, and an operation, this is the find on it. Find 2 operating on 3. As we have A operating on B to be what? A plus BA. Find what? 2 operating on 3. This simply means you are not considering this. This is just a guide given to you. The main formula is this. So like I said, the first one is A, while the second one is B. Just substitute. This will give us 2 plus 3 times 2. This will give us 2 plus 6 equals what? 8. Just like we were showing on the table we did before. The next one is minus 4 operating on 3. This simply implies that since your formula A operating on B equals A plus BA, this will give us minus 4 plus 3 times minus 4. We're going to have minus 4 minus 12 equals minus 16. That's just the solution for that particular question. Let's take a look at another thing. The inverse of a binary operation. Then we'll now go over to Examguide to handle past questions. Okay, inverse of binary operation, we have A operating on A inverse equals identity element. Okay, that's inverse of a binary operation. This operating on this equals E, where E is an identity element. Let's solve questions from past WAEC further mathematics using the Examguide app. Okay, question number 1. A binary operation is defined. Binary operation, this symbol should not be a problem. They can decide to use this or this. Anyone can go. They can even create something of this nature. It does not really matter. What matters, focus on the formula given to you. A formula must be given to you. Here it says A operating on B equals A dot B, okay, A minus B, I think it's A minus B, all over root AB. Okay, that's good. Find what? Evaluate minus 3 operating on minus 1. Remember, don't consider this anymore. Go with your formula. So the first number here is A. I write minus 3 minus 1. Okay? All over square root of minus 3 times minus 1. This will give me minus 3 plus 1 all over root 3. Minus 3 plus 1 will give us minus 2 all over root 3. But this cannot be your final answer, because under SOLD, whenever there is a root at your denominator, you think about rationalization. Now we are going to rationalize. Rationalizing this, we will have that minus 2 all over root 3 will produce root 3 all over root 3. This will now give us minus 2 root 3 all over root 9. Then what is the square root of 9? Square root of 9 is 3. Final answer becomes what? Minus 2 sub 3 all over 3. That becomes the solution. Let's take a look at another question. 2020. A binary operation is defined on the set of real numbers R by x operating on y, x operating on y x operating on y equals s squared minus y squared plus xy. Evaluate SOLD3 operating on SOLD2. Okay, just all you need to know, this one is A, why this is B. Or you can call it X because S was given at this point in time. Here, Y. So, formula S squared minus Y squared plus XY equals what? The first one, SOLD3 all square minus SOLD2 all squared plus SOLD3 dot SOLD2. If you take square root of SOLD3, it will give us 3. The minus square root of this, that's when you square it, to give us 2 plus SOLD6. 3 minus 2 equals 1 plus who? SOLD6. So the solution is what? SOLD6. Now let us look question under identity element. Let's search for it. We have done this one enough. Find the inverse of the element. Okay. Now look at a binary operation. This is defined on the set R of real numbers. M operating on N equals, here they are interested on N. Now let us see what will happen. The operation M operating on N equals who? M plus N plus 2. Whenever you are dealing with inverse of an operation under binary operation, you first of all get the identity element, which is E. Now recall that general formula A operating on E equals A. Here M and N were given to us, meaning M operating on this equals who? M. So the normal thing here, we're going to have M as usual is there plus E plus 2 given. Now, the operation M operating on N is what? M plus N plus 2. We are trying to get the inverse of this operation. Let's say identity element was not given here. Okay. If that should be the case, identity element is supposed to be here, but if that is the case, let's say that E equals transferring this here minus M minus 2. But we are told to solve it under N, meaning N operating on N inverse equals to identity element. Now, our identity element E, which is this, but right, they are supposed to give the identity element. Maybe there are some typographical error anyway. Here now, if this is this, following our formula, the first one here is still here is taken all over M, okay? Now, plus the second one, which is the N inverse, plus 2, equals to identity element. Okay, we are interested in inverse. What is the inverse here? N raised to the power minus 1 is the inverse there. If we keep this, that's making the subject of the formula. N inverse equals N plus 2 minus identity element. Assume that identity element is a number, let's say 2, or whatever, minus 2. It now means that inverse of this operation equals N plus 2 plus 2, assuming that this is it was given as minus 2. So at the inverse here now equals what? N plus 4. If identity element is 3, here we still change, meaning N inverse equals to N plus 2, then minus 3, to give us what? N minus 1. So in case it is given to us, but now we are trying to force it out because it was not given to us. What we have here is minus M minus N. Meaning when we substitute, we are going to have the inverse here equals identity element is minus M minus 2 equals the formula here N plus the inverse plus 2. Now taking this way so that we can get the clear information. N inverse equals minus M minus 2 minus N minus 2. We now have the inverse here equals minus M minus 4 minus N. So the inverse equals minus bracket M plus 4 plus N. Okay, let's trace another one where instruction will be given to us. That's taking the identity element to be so. Now let's look at that type. Okay. We'll check. Find the inverse of a binary operation is defined on the set of real number if the identity element under the operation is 0. Good. Can you see this one? Identity element was given. So you are not going to struggle with the question. Now, what do you recall? Recall that x operating on y equals x plus y minus xy. Good. But we're interested in formula of what? An inverse. So we're going to have x operating on S inverse equals to identity element. The second one, remember, is replacing this y so that you won't be looking for y again. So the identity element e equals 0. It was given to us. You now say 0 equals this, the first one. All right, x plus y, which is this, the inverse, minus x operating on the inverse again. You can see how it's going now. So 0 equals x plus, what is common here? Inverse is common. Factor it out. 1 minus x, okay? So that x raised to the power minus 1, which is the inverse, into 1 minus s equals to 0 minus x. I am transferring this so that I can make this subject of the formula, okay? Now, s inverse, the inverse, 1 minus s equals minus s. So making the subject of the formula means dividing through by who? 1 minus s. So s inverse equals minus s all over 1 minus s. You are done solving. Take the solution. You can see how this one is, because the identity element was given to us. If it is not given, it will solve in such a way that the question will come in such a way when you solve, you are going to see the value for it. You see the value of for what you are solving. Okay, let's go over to one more question. 2006. An operation is said by this is okay. Find the value of this now. This is not what we're looking for. We have done this type before. If this is, find the value of s. Good. A binary operation is defined on the set R of real numbers by A operating on B equals A squared plus B plus AB. A operating on B equals A squared plus B plus AB. Then find the value of s for which 5 operating on x equals to 37. Oh yeah, it looks scary, but not much. Just follow the format, you know. Now what do? Recall, I've told you, don't bother yourself about this. It's just to interact or communicate with this. This one, 5 is who? A. Ys is replacing B. Fine. So what you are going to do, since this formula, you were told that this formula is who? 37. You got to write 37 equals the first one, 5 squared, okay? Plus B, which is S, plus 5 times who? X, which is B. Can you see what's going on? So I have 37 here equals 25 plus who? 6x. So that 37 minus 25 equals 6x. This minus this will give us 12 equals 6x. Dividing through by 6, x equals what? 2. That's simple. This is just the end of this topic. The remaining ones under this question, you can try yourself. Don't forget to subscribe to our channel. Thank you.